Hi everyone, I'm Cecil Laia, application engineer from the consulting department Additive Minds from EOS. Our goal in Additive Minds is to train our customers and helping them to understand the technical issues and possibility of our technology. Within Additive Minds, each of us, we have a different expertise, and from my side, I'm an expert in design for AM and process simulation. Today's topic is Smart Fusion and dimensional accuracy. By developing Smart Fusion, EOS is enabling its customers to use less supports. Why do we want to use less supports? Because it's a waste of material, it's increasing the building time, and to warp up, it's decreasing or it's not optimizing your business case. But first of all, why do we have supports using the IPBF technology? Let's summarize. Supports have 5 different roles. First of the role is to keep the part in place. Keep the part in place attached to the platform. Keep the part in place when it may be touched by the recorder. So keep it in place against the recorder forces. And last point, when you are using IPBF technology, by exposing the part and then it's cooling down during the spreading of the next powder layer and then it's heating up again to the new exposure, you are building internal stresses inside your part. Those internal stresses, when they are released, may distort your part. So the supports are there to keep your part in place. 2 last roles of the supports are heat dissipation, and the supports are there also to stabilize the powder bed to enable us to print low angles or horizontal surfaces. With Smart Fusion, I said we are able to print with less supports. But what are the issues that we may face? I can list 4 of them. First, heat accumulation. Second one, part distortion, and part distortion may include then a recorder crash because the part, by distorting itself, can go up, so can pierce the powder bed and touch the recorder plate. Last point, the part distortion can cause a part or support delamination. And when the part is distorting, meaning that it's moving, you will have a part inaccuracy. So your part will not be inside your dimensional tolerances. But now I would like to show you that Smart Fusion does not have any negative impact on your part that you are printing. I will do this thanks to 2 case studies. The first one will be an Impeller printed in Inconel 718. The second one will be a Shroud printed in titanium. Let's start with the first case study. So we have an impeller of an external diameter of 380 mm, printed in Inconel 718, an 90 micron layer thickness process on an EOS M404. So when we want to print this impeller, what is happening if we are printing it without Smart Fusion and with Smart Fusion? Without Smart Fusion, we need internal supports. And those are a volume of around 1 kilo. Furthermore, we are printing a part that is not that massive with 4 lasers, meaning a lot of energy input, and it's too much for this part, so we need to slow down the process during building. So we are increasing the building time. With Smart Fusion, we do not need to add waiting time thanks to the thermal management. And we are decreasing the internal supports volume by 96%. No internal supports, meaning that we do not need to remove them, so we are also decreasing the post-processing time to remove the supports by 6 hours. Now let's see the part accuracy. On the left you can see the mechanical simulation, so the process simulation that we run before printing the part, and this was predicting a maximal deviation of 2.63 mm. On the right you can see the 3D scan of the part. So the part has been predeformed according to the simulation results before printed. In printing this predeformed geometry, we were achieving a maximal deviation of plus minus 0.25 mm. When you place 0.25 mm in front of this external diameter of 380, it's quite impressive to achieve this small dimensional tolerance by printing a part that is so huge. To conclude this first case study, we can say that Smart Fusion doesn't have any negative impact on your part accuracy. But Smart Fusion can do even more. Let's jump now to the second case study. We have here a shroud printing in titanium with a 60 micron layer thickness process on an EOS M304. Like the first case study, we'll see what is happening when we're printing this part without Smart Fusion and with Smart Fusion. Without Smart Fusion, we were forced to print the part with the bottom down. The bottom of this part is presenting a thin wall thickness and an horizontal surface. This configuration is forcing us to use a lot of volume supports to keep the part in place, because thin walls and horizontal surfaces are the worst case, and they are building a lot of internal stresses during the printing process. With Smart Fusion, we are able to print overhangs without supports, enabling us to print the part upside down. Thanks to this new orientation, we decrease the supports volume by 85%. Less supports means also that we are printing faster, so we're able to decrease the build time by 30%. And furthermore, without Smart Fusion, we had volume supports, when with Smart Fusion, we have only surfacic supports. Those are way easier to remove because we can remove them, we can break them by hand, when the volume supports have to be machined. Now, let's see again the part accuracy of this case. You have on the left side the 3D scan of the part printed without Smart Fusion, and on the right the 3D scan of the part printing with Smart Fusion. You can see for both cases the parts were predeformed according to the simulation results. Without Smart Fusion, we have a warp on the flange area, and we can see a maximal deviation that is higher than 1 millimeter. This is a part that cannot be used by other standards. With Smart Fusion and enabling this new printing orientation, we were able to achieve a maximal deviation of ±0.5 millimeter. So here, this second case study is showing you that Smart Fusion enabling us to use the technology in a more accurate way. To warp up this whole topic about Smart Fusion and part accuracy, Smart Fusion do not have any negative impact on your printed part accuracy. Even more, Smart Fusion enables you to use this technology in a more optimized way, enabling new orientation or removing internal supports. Thanks to that, you may even increase your part accuracy.